Welcome to Teddy Talks. In today's video, we are going to look at more numerical problems on projectile motion. Now, the problem at hand says that a particle is projected 20 meters to the horizontal and just clears the wall 10 meters high and 30 meters away from the point of projection. We are asked to find the speed of projection, that is initial velocity u, the velocity of the projectile when it is striking the building, that is the resultant velocity v. Now, when we are answering such a question, one, we should begin by looking at the sketch. Before we do anything, let's try to sketch. Let's have this question sketched here and summarized. Now, they are saying that this projectile of ours, it is projected at an angle of 20 degrees. It has an initial velocity u that we do not know. Now they are saying that on its way, it just clears the wall. So this wall, let's assume the wall is at this point. This is our wall, and this wall is 10 meters high. That is the wall. And the distance of the wall from the point of projection is 30 meters. Now, one of the questions says we find the value of u, and the other part of the question says we find the velocity at exactly that point. Now, you remember we said that the velocity here has components in both the y direction and the x direction, meaning that the velocity which they want us to get is a resultant at a certain angle alpha here. So now let us begin by answering the first question, where we need to find the initial velocity. But before we proceed, let us try to look at the data given in the question. They gave us arm of projection as 20 degrees. They gave us the vertical displacement as 10 meters. They also gave us horizontal range r as 30 meters. What do they need? Needed is u and v. So this is what we need. So let's begin with Roman numeral 1. How do we get u? Now, when you look at the data which we have, the only expression that can bring out u is if we can consider the equation of a trajectory. Now, if you remember the equation of a trajectory, we said that y is equal to x tan theta minus gx squared all over 2u cos theta squared. Now, I believe if we substitute in this value, we will get, in this formula, we are going to get the value of u. So let's try it out. Let's do that. Let's plug in the values we have. Our vertical displacement is 10 meters, y is 10, the horizontal range r is 30, tan 20 minus the value of g times the horizontal range, which is 30 squared, out of 2u squared cos 20 squared. Now, this is our expression. Let us press the calculator. Now, let's try to press this calculator here. 10 is equal to 30 tan 20. This gives me 10.92 minus 9.81 times 30 squared. This gives me 8,829 over, this is 2 times cos 20 squared. This gives 1.76, then 829 divided by that. So here we get the whole of this expression is 4,900. This is 4,999.3 out of u squared. Now this minus this, we shall definitely get this minus this, we shall get 0.9. Negative 0.92, sorry, is equal to negative 499.3 all over u squared. Therefore, u is the square root of 499.3 divided by 0.92. So let me put that in my calculator. 499.2 divided by 0.92, it gives me this value. Then I get the square root of the answer. When I get the square root of this answer of mine here, this gives me 73.4 meters per second. So that is the initial speed. That is the speed of projection. Now, question 2, we have answered. We have gotten the speed of projection, which is u. Question 2, we now need to find. The velocity. We said this velocity has two components, velocity in the x direction and in the y direction. So we can begin by quoting that v is equal to vx squared plus vy squared. But how do we get vx? We know that vx is u cos theta. Therefore, vx will be equal to 73.7 cos 20. Now, get the calculator. 73.7 cos 20. This gives me 69.25 meters per second. Now next is getting Vy. What is Vy? Vy is got from the expression u sin theta minus gt. Now the question is, do we know gt? The answer is no. We don't know t. What do we do to get t? We remember that the formula for horizontal range r is u cos theta times t, meaning our time here is the same as r out of u cos theta. So from this, our horizontal range was given as 30 divided by 73.7 cos 20. So that is 30 divided by 69.25. Our time here, we are getting it as 0.43 seconds. Therefore, our Vy will be equal to 73.7 sin 20 minus 9.81 times 0.43. So let us compute. 73.7 sin 20 close bracket minus 9.81 times 0.43. This gives my Vy as 20.99 meters per second. But we said what we need is the resultant velocity that is calculated from the expression. Therefore, we substitute. This is 69.25 squared plus 20.99 squared. So we compute that in our calculators, and my calculator gives me my resultant velocity to be 72.36 meters per second. But recall that velocity is a vector quantity that has both magnitude and direction. So next is getting the direction. But we saw that the direction, let's call it maybe alpha. If we come to our diagram here, we have gotten this velocity here. We now need this angle alpha. We see that angle alpha is got from tan alpha, which is opposite, and this is a vector of triangle velocity. This is a triangle velocities. This is Vy divided by Vx. Therefore, alpha is the tan inverse. It is the tan inverse of Vy. Our Vy was seen to be 20.99 being divided by 69.2. So we compute that 20.99 divided by 69.25. This we get the sine inverse. We get the tan inverse of ASA. Therefore, we see that our alpha is 16.86 degrees. We therefore conclude that the velocity of the particle, as it strikes the building is this value, 72.63 meters per second at 16.86 degrees to the horizontal. So here we shall have calculated, and we have successfully answered our question. Meanwhile, we peruse it through and go those 3 steps on your own. Try the question without looking at the solution and see if you come up with the same answers.